All right, so the force problems with constant velocity, we're going to do number 12 and number 13. So number 12, a person pulls a 50 kilogram object, so this is 50 kgs, along a level surface with a rope that makes an angle of 30 degrees with the horizontal. They're pulling, so that means upward. Okay, so this angle is 30 degrees. The force they exert is 200 newtons, so F 200 newtons. This will be Fy, this will be Fx, and of course there'll be a friction back this way. Coefficient of friction is 0.2. What is the acceleration? So 0.2, and you're looking for Ax. So again, you might want to find your two components first. So x will be the adjacent side, so cos. So cos of 30 degrees is equal to Fx over 200 newtons. So Fx should be equal to 200 newtons cos of 30. Cos of 30 is 0.866, so 86.6 times 2 should be 173.205 newtons. That's your x component. Your y component will be sine because it's the adjacent side. So sine of 30 is equal to Fy over 200 newtons. So Fy is equal to 200 newtons sine of 30. Sine of 30 is 0.5, so Fy is 100 newtons. All right, so now that we have our two components, we come back here. Where do I start? We're looking for Ax, but I still start in the sum of the forces in the y direction. This object is not moving in the y direction. Ay is 0. It's sliding in the x. And in the y direction, we have an Fn, we have an Fy, we have an Fg. If we call up positive, then Fn is positive, and so is Fy, because you're pulling up at an angle, so its y component is positive. Fg, of course, is down, so it's negative. Always solving for Fn, so take the other two terms over, so it becomes Fg minus Fy. So Fn is equal to Fg is mg, and Fy was f sine theta. Now I'm just writing it like that because soon there'll be a question coming where you won't know either the m or the f, and you'll need to keep it as letters. But here we know both, so we can find the number. So it's 50 kilograms times 9.81 meters per second squared, and then that's minus 100 newtons. So that's 490.5 minus 100, so 390.5 newtons is my Fn. Now if you want it, you could find your friction right here, okay, because they gave us the coefficient. So using the Fun equation, mu Fn. So 0.2 times 390.5 newtons. Move the decimal and double it. If you don't want to type it into your calculator, double 39, 78, double 0.5, 0.1. So your frictional force is 78.1 newtons. Now we go to the x direction. And that's equal to max. There are two forces in the x direction. Fx pulling forward, which we'll call positive. Friction pulling backward, which we will call negative, is equal to max. And we're solving for a, so divide by m. So Ax is equal to Fx minus friction over m. Fx we found earlier, 173.205 newtons. Friction we found just a couple minutes ago, 78.1 newtons. And that gets divided by 50 kilograms. So this is going to be like 95.1 divided by 50. So 1.9, can I trust that? 1.90 meters per second squared, assuming I can trust the number on the sheet. Okay, so that is number 12. Should I do it out just in case? 173.205 205 minus 73.1 divided by 50. Oh, I think I screwed up. Oh, okay, times 50 minus 5 divided by 50. So 1.90, it's 21 are the other two digits there, in case you want to. All right, next question, number 13. A person pushes a box of mass 80 kilograms along a level floor. They make their arms make an angle of 25 degrees. Okay, so they're pushing, and so this angle here, pushing downward at an angle. So this will be my Fx, this will be my Fy, and of course friction will be opposing. Force that they're exerting is 400 newtons. So this is 400 newtons. Coefficient of friction is 0.25. And it wants to know what is the acceleration of the box. Okay, so again, you can do x component is the adjacent side. So cos theta is equal to fx over f. So fx is equal to f cos theta. It is not going to be a pretty number now, okay, because cos of 25 is not a pretty number. So 400 newtons cos of 25, I probably wouldn't even get the answer here because it's going to end up being rounded. I'd probably wait until I stick it in. Instead, I would find the expression for Fy. It's sine theta, so Fy would be equal to F sine theta. And again, not going to be a pretty number. 400 newtons sine of 25. I probably wouldn't find it till I needed it. I would then go to the y direction. This object that the person is pushing, this box, it's not moving in the y. So there are three forces in the y, Fn, Fy, Fg. If we call up positive, Fn will be positive, and the other two will both be negative because this time you're pushing down at an angle. So Fn will be equal to Fg plus Fy. Fg is just mg, and Fy is F sine theta. And if you really needed to, you could find your values now. So 80 kilograms times 9.81 meters per second squared plus 400 newtons times the sine of 25. It's not going to be pretty, but okay, so sine of 25 times 400. So that term is 169, and you're going to add it to 80 times 9.81, and so you're going to get a normal force of 953.8473 newtons. Keep all those numbers in your calculator, all the rest of the decimals. Don't round it because you'll need it. Go to the sum of the forces in the x direction is equal to max. We have x going one way, friction going the other, equals max. So Fx is really 400 newtons, cos of 25. We're solving for A here, so minus friction, which you actually could have found, friction is equal to mu Fn. I'm going to run out of time. Friction is equal to 0.25 times 953.8473. So get your frictional force, multiply by 0.25, it's 238.4618 newtons, and so put that up here, 238.4618 newtons. Solving for A, so you need to divide by m, and m was 80 kilograms. So AX equals, so that's a negative plus 400 times 25 cos divided by 80. And you should get 1.55. Look at that, it works. 1.550766 meters per second squared. Okay? Hopefully these are getting pretty good for you.